Hey, Ag Teacher Thoughts here coming at you with another video. So we're going to talk a little bit about some of the parts that came. I've unboxed them, but doesn't mean we can't talk a little bit about them. Tried to shoot a live, nobody showed up, so we'll do it. We'll do it here. So what we're going to talk about is our heater that we've been creating for our greenhouse. So the heater is a closed loop system. You can go back and see some of the videos there. But some of my components arrived that we needed to have, and I'm going to tell you a little bit about what they are and kind of why they're there. So, why are we going to be using the units that we have? So the first thing that I need to talk about is our burner unit. Yeah, this will probably look better if you have it like that. So that is our burner unit that we're going to be using for the greenhouse. This is a standard propane torch. With this all the way, see if we can get it back in here. All the way back in here, there's a little itty bitty tiny hole that is drilled in there. It's probably just a few thousandths of an inch across. So that is what is our jet. So that's going to be putting off our propane gas. So that's going to be coming out that tiny hole. This is our mixing chamber. So this is where the air is drawn in. So our oxygen comes in here. We're just using standard atmosphere on that. It does have a little bit of a thermal sink here that allows some of that heat to come off so it's not transferring back down the torch head. So that is our air inlet, our mixing body. And then out down here towards the end, this is actually where the flame is maintained. So this is our combustion chamber out here. So it mixes, and the flame generally is hidden back in here. You can see how this is kind of a different color. This is a torch that I've used for quite some time. It's a Benzomatic. It's one of my favorite, excuse me, my favorite torch burners. And it's one I can't seem to get anymore. It's generally used for MAP gas. So it's a MAP gas head, but I found that it actually works better than the standard propane nozzles that they have available. So this is the same idea. So it still has a little tiny jet here, hooks on the top of your 1 pound propane tanks. I do have an adapter that will actually take it up to like the great big, people call them 5-gallon cylinders, but I think they're 40 pounds, something like that. This is your combustion chamber, or your mixing chamber right here. Your combustion chamber is actually out here. So it ends in this flame distribution unit there. So you can see there's a lot of similarities, but then this section here is different. And then the mixing device they have there to spread out the flame is not present in the MAP gas one. I've tried both units in our test rig. This one, when put into the test rig, just because of the design and the setup of the flame that comes out, it produces a harmonic. So imagine like a single note didgeridoo. It's not great. It gets fairly loud. When I set it to heat setting, I want to heat the greenhouse. It's letting off a lot of noise, which is not great. So we're going to be using this style burner. Now, I am using an off-the-shelf burner rather than one built by myself, just for safety reasons. We'll put air quotes around that because this is nothing guaranteed. This is all a homemade, home build setup. So this is the burner unit that we're going to use. Now, I had comments by people about you're going to flood the neighborhood with propane if your burner ever goes out. The test video I shot, yeah, there was nothing to control that flame. It was something I monitored the entire 2 hours that it ran. So I was there checking that unit all the time. So the flame wasn't going out. It was a still air night. I didn't have risk of it blowing out, but I monitored that burn the entire time. The reason I didn't show it on video, it's kind of boring to see someone sitting there watching a flame burn. So what we're going to do is we are going to have another safety device that comes in line. So let's move this burner unit out. There you go. You can see that there. So what we're going to bring in is, this is one of my Amazon purchases that I was waiting for. This is a flame sensor, and This is a shut-off valve that will shut off the unit if there is no flame. So this is what's called a thermocouple. So this goes pretty doggone close to the flame. I'm going to have to adjust it and see how this one works best, but generally, like, this will be over your pilot light. So with us, since we're using a full flame burner for our heat, this will probably be adjacent to it. So the flame will run past it, but not actually make contact. Because you can overheat these, and I don't want to overheat this. With this, to get a thermocouple to work, you do actually have to push down on a plunger, and you have to hold that until the thermocouple completely heats up to working temperature and keeps that valve open. So this is a mechanical flame sensor. So we don't need to have electricity. We don't need to have any other devices there. So that unit is going to go, here, let's put it like this. It's going to go down here. This valve body is going to run off to another side. But that will keep, basically it'll monitor our heat, make sure our heat is there, and it'll shut off the flow of propane if there is an issue. Down in this area here, I'm not going to go bring in a chunk of pipe, but this is going to be basically our radiant heater tube. The radiant heater tube actually is a U, so the flame comes in one side, the exhaust goes out the other. And you can see that in my other videos. So it's a circuit. So we're not putting exhaust gases in the greenhouse. We're not having that risk of uncombusted propane affecting the foliage of the plants. We're not having the risk of carbon monoxide building up in there. It's just best to have a sealed combustion chamber, and then it vents and exhausts outside. There's a few more things that I'm going to put on that exhaust. I'm probably going to put a little bit more of a piece of extension, and then probably if you think about a modern furnace, most of those, the intake and exhaust is actually PVC pipe, which is really weird to think that you're going to have like flames, exhaust from a flame going out PVC, but it's cooled significantly. We're going to do the same thing with our burner unit. We're going to have a chunk of PVC that comes up, and it's actually going to draft those exhaust gases up and beyond the side of the greenhouse. But it's going to allow airflow to do that so that the pipe doesn't overheat. Along the way, we have one other thing. So we do want this to be a self-contained unit. So when I am using propane, there's a lot of heat involved, and I want to use some of that heat to do work other than just to heat the greenhouse. So that is where I have our next purchase. This is also an Amazon purchase. This unit, I think, was $17. This was somewhere right around $20. And this is a heat-powered fan. So this uses a device called a Peltier, and the Peltier takes heat and turns it into electricity. It can also take cold and turn it into electricity. But with this, there is an electric motor that turns this fan. Yes, I know the blades are out of balance. I will work at balancing them. It's like one of the first instructions they have is straighten the fan blades. So they know it's a quality issue. They just don't fix it, which is weird because I'm in manufacturing and I don't send bad quality out the door. So it's kind of weird that they feel it's appropriate to send bad. Yeah, I've still got to adjust that. Yeah, I think some of these are high and some of them are low. But anyway, so this is powered by a small electric motor. And how this works is we have what's basically a heat sink down here. And this is taking the electricity that is coming off of our exhaust. So we're going to have a bracket that's going to connect this to our burner unit. And it's going to take that heat and it's going to channel it up this narrow fin of the aluminum. So it's going to make sure it's not going to overheat the Peltier. Okay. And then in here, there's a white unit. I think you can see that on camera. Let's make sure. Yep, there we go. So there's a white unit in here, and that is the Peltier. So that is a special device that as heat transfers across the unit, so it's got to go from a hot side to a cold side, it creates an electrical current, which powers, in this case, a little electric motor in the fan. So this is all extruded aluminum. So this is designed to radiate out that heat. So it's taking heat, like a large amount of heat here, transferring it across a Peltier, turning some of that into electricity, and then radiating the rest of it out into our greenhouse environment. So this is going to be a way for us to move air in the greenhouse solely using the heat of our radiant heater. So yeah, heat comes in, goes up the extrusion, across the Peltier, radiates up in here, and then that creates the electrical current and turns the motor, which is right down in there. Yeah, you can kind of see the red wire. Yeah, okay. That turns that fan blade and helps move. I'm assuming it's going to move like that. You know, it's probably not going to move a whole bunch of air, but moving some is good. And for 20 bucks, I figured that would be something that will work. It did come with a couple other things that we're probably not going to use. One is this. This is supposed to be an aroma pod, and this is one of those things. This is kind of like a Temu idea. It shows this as being like this ginormous thing, but it's literally like a little tiny pill container or a hide-a-key. I kind of thought this would be like a pocket survival kit, you know, like throw some matches in there and a couple fish hooks and some fishing line, but we don't need this. That was thrown in there anyway to make it seem more valuable. The other thing we will use is there is there's a thermometer, and this fits right on there. There's a magnet, so it should stick to stuff. Yeah, there we go. So that'll stick right to our burner unit, and we can figure out kind of roughly what the temperature is that's coming off of there. My goal is to have the air exiting somewhere around 120, 150 degrees. You know, still warm enough that it's going to draft real well, but not so hot that we're actually losing value of our heating unit. So this is the other thing that it gave us. So that'll be somewhere out in here. Peltier fan is going to be out in here, and this is going to be in the trash. Okay, so that is a lot of our system there. So kind of excited to see how this goes. It should work really well. I'm hoping. Just, you know, without the actual fan, it heated the greenhouse pretty well. You know, we went from, I think the outdoor temperatures were in the 20s when we started it, and the indoor temperature of the greenhouse after about 2 hours was 62. So, you know, and that was with just a medium to low flame. If we have a higher flame, I'm sure we can boost that a little bit higher. But there you go. That is the components that arrived today. So that is what arrived, what we're adding to our greenhouse build. As always, I hope you learned something. I hope you enjoyed. Ag Teacher Thoughts, out.